Ja, das Beispiel von Dr. Stieler hat gezeigt, wozu unsere Graphical System Design Software LabVIEW imstande ist. Dabei war vor allem das Automatisieren eines Verfahrens maßgeblich. Das Automatisieren ist seit der Einführung der NIGPIB-Schnittstelle möglich und erlaubt es uns seither, Rechnersysteme an Messgeräte anzubinden und somit Prüfschritte zu automatisieren. Seither haben Sie und NI gemeinsam mit innovativen Ideen daran gearbeitet, den Bereich automatisierten Test produktiver, aber auch kosteneffizienter zu gestalten. Um uns nun über die aktuellen Innovationen und auch Erfolge im Bereich Automated Test zu informieren, bitte ich meinen Kollegen Travis White auf die Bühne. Please welcome Travis White. Morning, Travis.
Hi, Daniel.
So, Travis, tell us, how are we disrupting automated test?
Sure. So the best choice for increasing the performance and lowering the cost of automated test is PXI, a modular hardware platform we invented 17 years ago. The simple idea of taking PC-based instruments and adding a rugged frame with integrated timing and synchronization was and continues to be the right idea at the right time. But the true measure of a platform isn't what it's done in the past. In many ways, PXI is just now hitting its stride. Market reports projected at well over $1 billion in a few years' time, with growth that's outpacing that of traditional box instruments. At this point, if you're about to build an automated test system and you're not at least considering PXI, then you might be taking a big risk with your test strategy. Why? Because PXI combines disruptive innovation, like user-programmable FPGAs, with mainstream user requirements like traceable calibration and worldwide support. And it's these two vectors, disruptive innovation and mainstream user requirements, that we're going to look into in more detail today.
Sounds good. So where do we start?
Let's begin with production test. To get us going, let's take a look at a video of how analog devices used this platform-based approach on their semiconductor production floor.
So our customers have application in handset, wireless communication, and base station. Each of the area requires some level of dynamic performance. There are many standards, and to put all this together in one single part and test it is a significant task. NI's 26.5 GHz signal analyzer, I believe, has the RF performance we need for measuring the DAX performance, but also it has the processing power that allows us to reduce the test time and so the cost of tests.
When we did performance metrics between the 26.5 gig vector signal analyzer and our existing bench test equipment, we saw about a 30% savings in test time for a lot of the specs that we were testing. We can run more data in an 8-hour day than we could have with other equipment. So that's something that it should help us speed up our evaluation time.
If you use the same hardware, if you use the same software, then you can develop characterization test program and leverage that characterization program for production test. And that is one way you minimize the development cost and, more important, time to market for us. This is where NI can bring a significant benefit to customer.
Okay, so ADI just showed us how they used a custom in-house tester design to replace their traditional big iron ATE. And using PXI, they were able to significantly reduce the cost, size, and footprint of their MEMS microphone production test system. But ADI is not alone. We estimate that there are more than 700 deployed semiconductor production test systems currently based on PXI.
Okay, Travis, so can you give us some more insight into the current state of the semiconductor industry?
Sure. So the semiconductor industry is in the midst of a major transition. What used to be driven by Moore's law, thanks to the growth of the PC industry, is now being driven by more than Moore, which started with the proliferation of smart mobile devices, and moving forward, the Internet of Things is going to drive wireless capabilities and analog sensors into just about every integrated chip technology. And while the cost to manufacture these devices has decreased rapidly, the cost to test them has stubbornly remained flat or even increased. Traditional ATE, built on proprietary architectures, was good for traditional Moore's law, but it has a lot of difficulty scaling to meet the RF and analog demands of these new chips.
So, Travis, what's NI's role in changing that dynamic?
Well, NI is sitting on a massive collection of both hardware and software IP that we've repeatedly demonstrated making the most difficult semiconductor measurements. PXI's high throughput and low latency is ideal for the production floor. LabVIEW and Test Stand are great for code module development and test program sequencing. And we have a network of hundreds of applications engineers that provide services and support around the world. But the #1 request we get is to make our capabilities easier to integrate into the semiconductor production environment. So in that light, we've decided to tie a bow around our platform capabilities, and we're excited to launch the new Semiconductor Test System, or STS. The STS brings the openness and flexibility of PXI to the semiconductor production floor, with features like handler and prober integration, spring probe device under test interfacing, configuration management, data reporting, and system-level calibration. It comes in 3 sizes, which can scale to meet the pin count and site count requirements of a given application.
Well, wait, Travis. So I think there's at least one person in the audience who now thinks like, well, they just developed a turnkey ATE solution, right? So what do you say to that?
Well, it's true that with this announcement, National Instruments is delivering systems with a higher level of integration, but we're doing it in our way, completely based on standard off-the-shelf components which are open and customizable to every user. We've also abstracted things like test program development and load board design so that both our end customers as well as our global network of alliance partners can do turnkey system integration. So the STS is very much aligned with both our business strategy as well as our technology platform.
Okay, so Travis, can you tell us how this beauty came to be?
Well, we definitely did not develop it in a vacuum. We worked with many lead users who not only gave us feedback, but they even deployed our early engineering prototype units onto their production floor. And with some optimizations, we were able to get up to 500,000 parts per day of test throughput on a single site. We also worked with industry experts like Reed Ashman and Sisu Devices on the elements of the system that we wanted to get correct the first time. Now, another key piece of feedback we got is that RF capability is incredibly important for the STS. The semiconductor ATE world is very familiar with the idea of an RF port module, which expands a single RF resource to many pins on a device under test. Well, National Instruments has the perfect building block in the low cost and small size of the vector signal transceiver, and along with a newly designed RF port module for the STS, we're able to get up to 48 ports in a single STS configuration. And with multiple VSTs, this opens up the door to highly parallel and very affordable RF test, which is going to be important on the new wave of chips that we're going to see in the market. And it's all calibrated at the load board, which is important for traceability. So in every way, the STS makes PXI ready for the semiconductor production floor.
Okay, so you mentioned lead users. So how was the STS received by those lead users?
Sure. So a good example comes to us from IDT. IDT is a semiconductor company based in California with offices worldwide and manufacturing operations based in Penang, Malaysia. IDT makes products for high-performance computing, communications infrastructure, power management, and timing. Now, IDT was facing a lot of the standard manufacturing test business challenges, like reducing cost and increasing utilization by adopting standard test platforms. They found that working with big iron ATE required a very large capital investment and was also very cumbersome to scale as their devices changed, with RF and analog capability often ending up bolted on to their existing testers. To alleviate some of those problems, they also worked with custom in-house tester designs, but those had the drawback of requiring a team of engineers to develop and very limited support.
Okay, so tell us how IDT and NI worked together to find a solution.
So IDT had been considering PXI for quite some time, and the STS provided the integration features they needed to take the next step. Because it's built on PXI, the STS is going to allow them to grow and enhance their tester platform as their devices get more complex. And they're going to be able to retain their capital and engineering investment instead of having to throw that away and start over like they were used to with previous versions of big iron ATE. So currently, IDT has 3 systems up and running in Penang, and they're looking for further opportunities to migrate over to the STS based on the increased performance and lower cost that it offers them. So we're very excited to see their progress, and this is just the beginning.
Well, it's great to see the impact that PXI brings to the ATE market. So thanks, Travis, for sharing that with us.
Thanks,
Thank
Daniel.
you.